Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're learning about the gradient at a point on a curve. So as we always do, let's start with prior learning. So far we've learned something to do with gradients and curves. We've learned the average gradient of a curve between 2 points. So if we had a curve and 2 points on the curve, if we were to draw a chord, which is a line connecting those 2 points on the curve, then if we worked out the gradient of that chord, that would tell us the average gradient between the points, in this case x is 1 and x is 5. And that's useful when you're trying to work out the average speed or the average acceleration, etc. But we want to be a bit more precise in this particular lesson, and we want to try and work out the gradient at a point. Not the average gradient between 2 points on a curve, but the actual gradient at a point on a curve. So in the second picture I've got here, I've got a point on that curve and I want the gradient at that very precise point. So we're going to try and think about how we might do this. I'll come back to how we do this in a second, but let's just start with some terminology and definitions. So let's take a picture and we've got a curve and we've got point A on that curve. Imagine I said your objective was to draw a line that touches the curve at point A. So you might get your ruler out, and if you drew a straight line along there, that wouldn't just touch the curve there, it actually intersects the curve there. You want it to touch the curve, so you'll have to shift it like this. That intersects at A as well, so that would be no good, and you'd have to shift it more and more, and you play around with it a little bit until you get that looks pretty good. That line there seems to just touch at A, and if you draw a straight line along there, that would be a tangent for us. So let's draw a straight line along that, and that is what we call a tangent. It would even be a bit more precise, maybe even a bit up like that. And we have drawn there a tangent to the curve at point A. So let's write some definitions out. Here's a picture, and a tangent at point A on the curve is a straight line that just touches but does not cut the curve at A. That's what a tangent at point A is. And here's a very important definition we need to learn. The gradient of the curve at point A is defined as the gradient of the tangent to the curve at point A. So if we want to work out the gradient of the curve at A, all we need to do is we need to draw a tangent in, and we need to work out the gradient of that tangent, and that will be the gradient of the curve at point A. Okay? And that's what we're going to do in this lesson. And just before we go on, let's just go back to the definition of a tangent, be super clear what it is and what it is not, very importantly. So again, a tangent at a point A on a curve is a straight line that just touches but does not cut the curve at A. Here are some examples of tangents. They're straight lines that touch the point on the curve A. And here are some non-examples of tangents, so things to be careful of in case you get confused and think they might be tangents. So this first one here is not a tangent because it doesn't touch the curve at all. It doesn't touch it as A, but it doesn't touch the curve at all. So it's certainly not a tangent. The second one is not a tangent. It crosses or intersects the curve at A, but it doesn't just touch it. Okay? And the last one is not a tangent. It's close to being a tangent, but you can see that it actually crosses at A. Okay, so you've got to be careful. The tangent can only touch, it cannot cross. Alright? So let's go back to our original question that I was framing to you. I said we're really good, and we've done before, at working out the average gradient between 2 points on a curve. We work out the gradient of the chord connecting those 2 points. But if I wanted to work out the exact gradient at a point on a curve, I would have to draw myself a tangent, work out the gradient of that tangent, and that would tell me the gradient at that point on the curve. And that's what we're going to do in this lesson with various examples. So here's our first example. Pause and have a go. So we're asked to estimate the gradient of the curve at point A, and why is it an estimate? So we get our ruler out, and we twist it a little, and we try and draw it, we try and put it towards the curve at point A such that it touches at A but doesn't cross. So you'd extend it along something like this, and you would draw a straight line, and it would look like that. My advice is draw that straight line nice and long and as far as you can, because you're going to have to work out the gradient of this tangent, and you're going to hopefully try and pick nice easy coordinates that lie on that line to do so. So you draw it nice and long so you've got every opportunity of finding some nice pairs of coordinates. So can I find some here? Well, that looks like a lovely coordinate right on a mark 1 0, and that one does as well. It's at 4 4. So if we try and work out the gradient of this tangent, that will be an estimate for the gradient of the curve at point A, and we'll talk about why it's an estimate in a second. So why don't we label these points here maybe X and Y, and X has coordinates 1 0 and Y has coordinates 4 4, and to work out the gradient we do the difference in Y's divided by the difference in X's. So start big Y, we do 4 take away 0, the number above it, divided by 4 take away 1. And that would give us the answer 4/3. Now that is the gradient of the tangent that we drew, and therefore that is a good estimate for the gradient of the curve at point A. The reason, of course, it's an estimate is we drew the tangent by hand. Whenever you draw a tangent by hand, there's a certain degree of inaccuracy. So we'll write that as our reason why it's an estimate. It's an estimate because we had to draw our tangent by hand. Okay, next question. Pause and have a go. Same question, estimate the gradient of the curve at point A, and why is this an estimate? Ruler out, twist your ruler, and try and draw a line such that it just touches the curve at A, and extend that line as far as you can. And we're trying to find two nice pairs of coordinates that lie on this blue line to help us with an accurate calculation for the gradient of that tangent, which is going to be an estimate for the gradient of the curve at point A. That looks like a nice point, which I'll call X at 0 2, and that also looks like a nice point, I'll call it Y, it's at 4 8. So X is at 0 2 and Y is at 4 8, and we're going to work out the gradient by difference in Y's divided by difference in X's. So what we're going to do is we're going to take this Y ordinate here, 8, and we're going to do 8 take away the number above it, 2, and then we're going to take this number and 4 take away the number above it. So it's going to be 6 over 4, which simplifies to 3 over 2. And again, it's an estimate because we drew our tangent by hand. Next question, pause and have a go. Same idea here, we're asked to estimate the gradient of the curve at point A. We get our ruler out, we twist it, and we twist it with the objective of drawing a line that just touches at A. Something like that is a bit extreme, maybe a bit like this might do. And we draw a line and it would look something like that. And now we try and find some nice coordinates on this line so that we can work out the gradient of this tangent, which will be an estimate for the gradient of the curve at point A. So can we find some nice ones? Well, A itself looks quite nice. A is at 1 4, and another nice one is maybe this one. It's at 0 8 here. Okay, so our pairs of coordinates, we've got 1 4 and we've got 0 8, and we can use those to work out the gradient, which is going to be the difference in Y's, which is 8 take away the number above it, 4, divided by the difference in X's, which is 0 take away 1. Very important you do it in the same order. If you pick this Y first, you have to use this X first. And that's going to be equal to 4 over negative 1, which is just going to be negative 4. And remember, it's an estimate. We didn't have to write it this time because we had to draw our tangent by hand. Next question, pause and have a go. We're asked to estimate the gradient of the curve at the following 2 points, so 3, -4 and -1, 0. Step 1, mark those points on the curve. So I've marked the point 3, -4 and -1, 0 here. And we are now going to get a ruler out, and we're going to twist our ruler so that we can have a line that just touches at both those points. And it would look something like this, and we draw 2 long tangents, and we will use those tangents to estimate the gradient of the curve at these points. So let's start off at 3, -4. So this is this one here. Can we find some points nice along there? Well, 3, -4 is a nice point, so we'll stick with that. And that one also looks like a decent point. That's at 2, -7. So our points are at 3, -4 and 2, -7. So the gradient is going to be equal to the difference in y. So -7 subtract -4, -7 subtract -4, divided by 2 subtract 3. And subtracting a negative is like adding, so that's -7 add 4, which is -3, divided by 2 take away 3 is -1, and that just gets us 3. You could have also just seen that by as you go across 1 you seem to go up 3. As you go across 1 you go up 3, so the gradient's 3 there. What about this one over here? Do we have 2 good points? Well, this one's good enough. So this one's at -1, 0, as we know that's in the question, and this point here would be good. That would be at 0, -5. So what we're going to do is we're going to work out our gradient by the difference in y, so -5 take away 0 over 0 take away -1, and that would give us -5 on top, and it would give us +1 on bottom, and that gives us a gradient of -5. Kind of makes sense, because as you go across 1 you go down 5. And therefore both of these are the gradients of the tangents we've drawn, and they're good estimates for the gradients of the curve at those points as well. Next question, pause and have a go. Using the graph, estimate the coordinates of the point where the gradient of the curve is 0. Well, when the tangent is like this, it's a positive gradient. When it's like this, slanted downwards, it's a negative gradient, and when it is horizontal, it is 0 gradient. So our tangent must be like this, and where does a line just touch with the 0 gradient? There. And we draw that line in, and the coordinates of the point where the curve, the gradient of the curve is 0 is at 2, 2. And that's it for this particular video. Thanks for watching.